everybody. Today we're going to be talking about overlapping triangles and proofs in overlapping triangles. So first, make sure that you're on lesson 4. It looks like this. Okay. And we're going to start with this first one. So notice that you want to prove triangle ABE. I'm going to highlight this one. Okay. Is congruent to triangle ACD. So these two triangles overlap. So what's usually helpful with overlapping triangles is if you redraw the triangle outside and then relabel it. So this is B, A, B. This one I'll put over here. This is D, A, C. So now let's look at what we are given. And I'm going to mark it on both my ones that I separated and the ones on the original diagram. So we're told that AB is congruent to AC. Or let's mark it here, AB congruent to AC. Okay. Now we're told that BE is congruent to DC. So that's kind of harder to mark on the overlapping one. BE, we'll do it like that, congruent to DC. Here it gets tricky, that's why it's better to draw it out separately. And then we're told that angle B is congruent to angle C. Put it in our overlapping diagram. Here we go. So now triangle ABE congruent to triangle ACD. And we can see pretty easily what method we're going to use. Side, angle, side. So once you draw it out and separate the triangles, it's a lot easier to see what method you should do and where the sides are. Let's just write it out. So we were told that AB is congruent to AC. That's given. We're told that BE is congruent to DC. That's also given. It's not nice and easy, they gave us everything. Angle B is congruent to angle C. Again, given. So we have everything we need, right? We said it was side, angle, side. We have all of those pieces. So triangle ABE is congruent to triangle ACD. If we want to go back up and look, the method was side, angle, side. Let's take a look at another one. Okay. Number 2. Number 2 tells you you want to prove triangle EAB. So let's outline it. If you have highlighters, you should do that too. Triangle EAB is congruent to triangle DAC. So let's take them out. So here's this one. Here. And then it's really helpful if you label your triangles. So this one is E, A, B. And the green one is A, C, D. So now that they're separated out, it's easier for us to see what we have. So they told us that AD is congruent to AE. So here's AD, congruent to AE. And also that angle D is congruent to angle E. Now, we only have 2 things. We have a side and an angle. We still need one more thing. So a lot of times with overlapping triangles, there's something that we're going to use that's reflexive. So think about it for a second. What do these 2 triangles share? What complete side or complete angle do these 2 triangles share? So if you look, it's angle A. Angle A is going to be congruent to itself. So let's mark it on each of our separated diagrams. So now you can see that we can prove triangle EAB congruent to triangle DAC by angle, side, angle. Angle, side, angle. And now it's just a matter of writing it out. first given, AB, congruent to AE, and that's given. Angle D, congruent to angle E, also given. And we just put the reflexive, angle A, congruent to angle A, that's the reflexive property. And triangle EAB, congruent to triangle EAC. And we said that was angle, side, angle. Let's just take a look at our diagrams again. Angle, side, angle on both of the triangles. I'd like you to skip ahead all the way to number 7. Okay, so skip all the way to number 7. We're going to look at one more overlapping proof, and then the rest we'll practice in class tomorrow. Okay, so here we have, we want to prove that triangle AMB is congruent to triangle CND. So let's highlight what we have. AMB congruent to triangle CND. So you can see that they overlap. So let's take them out so we can see it better. So I want you to redraw it right now as I'm doing this. So A, M, B. Redraw the other one. Put it here. This is C and D. So let's look at what we have. We're told that AM is perpendicular to NM. So AM perpendicular to NM. That's going to give me a right angle here. And if I put it on my separated diagram, it's right there. And we're told that CN is perpendicular to MN. CN, MN. So that's here. And again, on my separated diagram, that's right there. Okay. I'm told that MD. Now let's look at this. MD, it's right here, is congruent to NB. Well, you can tell that's not enough. So when I don't have enough, I'm going to need to use the addition postulate. So I can't really mark it on my separated diagrams because it's not really enough. It's here and here, right? It's not enough of the side, so we need to use the addition postulate. I'm going to make a little note there on the side. Addition. And if you notice, the piece that they overlap is DB. So that's what I'm going to use as my reflexive, and we'll add that in. So it will eventually give me side MB congruent to ND. And then I'm also told that angle ABM is congruent to angle CDN. So ABM is here, CDN is here, and it's a lot easier to see on our separated diagrams, ABM, CDN. So if you look, once we do everything we need to do, it looks like we're going to have angle, side, angle. Okay. This one's a little longer to write out just because there's more steps, but it's definitely doable. So I'd like to start with my first given. So my first given is AM perpendicular to NM. And I'm going to list the second given as well because it goes in the same steps here. CN perpendicular to NM. That's given. So now we can say that angle M and angle N are right angles. You know the reason, perpendicular lines form right angles. Now, since we're not doing hypotenuse leg, we're just doing angle, side, angle, we're going to say that those two angles are congruent to each other. So angle M is congruent to angle N. And we know that reason is all right angles are congruent. it's giving me an angle, so I'm done with that. Let's look at our next given. That was when we didn't have enough. MB, MD is congruent to NB. Now we're going to be using the addition postulate. So if you remember what we taught you in class, when we do the addition postulate, we state the given, and then we look for the reflexive piece. We said that was dB. That's this piece. dB is congruent to dB. That's the reflexive property. And now we want to add them. We add these together. So MD plus dB is congruent to NB plus dB. And that's the addition postulate. And then now we know the last step is substitution. We're just looking for what's another name for MD plus dB. Let's go back to our diagram. MD plus dB is MB. Now we need to look for another name for NB plus dB. So NB plus dB is this, NB plus dB. So that's ND. Let's fill that in. And that's substitution. Just as a quick side note, remember these were your 4 steps for the addition postulate. So that gave us the side. And then lastly, we have one more given. Angle ABM is congruent to angle CDN. That's given. Now we have enough information, we can go to our proof. Triangle ANB is congruent to triangle CND. Let's just look up again real quick. Make sure we have the right method. Angle side angle. Angle side angle congruent to angle side angle. Okay, so that was 3 proofs with overlapping triangles, and in class tomorrow we'll be working on more of them.